Evening, Miss.
All right, welcome, everybody. Welcome. All right, so as you will probably noticed that we're only gonna have one class for this week, which is obviously going to be today because Wednesday is Ash Wednesday. It's a public holiday, so you know that we're not gonna have any class on Wednesday. All right, and I can't promise that I'm gonna do any pre-recordings or anything like that. So I do strongly recommend that you guys use the opportunity to, use the freedom, right? The Wednesday, the Thursday, the Friday, and whatever time you have until we meet again next Monday. To make sure that we shuffle up some stuff, organize up ourselves, you know, review what we need to review, and put some things in place because we're fast approaching March, and March is a very intense month. We only have 2 months left and about four topics to go through. So we're not gonna really have much time. We're fast approaching. Remember, the exam is on May the 6th. All right. So please make a note of that. The exam is on May the 6th. So we literally have 2 months, 6 days, and maybe another week. All right. So we don't have much time left. We have approximately 16 or 18 or maybe 20 classes left. So let us make it count while we can. All right. So but today now we're gonna pick up from where we left off last Monday, which would be Miss Gentles. You're my little supervisor,
We stopped at solving quadratic equations.
Lovely. Fantastic. So we should be going to simultaneous equation tonight, and then that would be the end of algebra. All right. So we are fast approaching the end of algebra. Let me go ahead and begin to share my whiteboard with you. So tonight we're going to wrap up algebra. Finally, we come to the end of the last topic, right? So we're going to go through some algebra tonight. The last step of it, simultaneous equations. We're going to do a quick little review on quadratic equations, and then that is it. We're going to move on to something new. In our Wednesday's class, what are we doing? Transformation?
We did rotation first.
Okay. Good. All right. So that means the next week, Monday now, ladies and gentlemen, we're going to move into geometry, right? I wanted to start trigonometry, but I feel like I want to take care of the angle section first, and then I move into trigonometry. All right. So that's what we're going to be focused. So next week, Mr. Gentles, just jot that down for me, please. That next week we're going to be starting geometry. All right. Well, the topic is going to be angle geometry. Angle geometry. And that's going to lead us into trigonometry. And then, of course, we're going to look at, for Monday now, we're going to look at, for next week, Wednesday, God's Spirit Life and Win a Good Health. We're going to pick up at enlargement, wrap up that next week. And then the other Wednesday, we'll move into a new topic. So March will be on 3 new topics for March. Geometry, trigonometry, and hopefully I think that we should be able to move on to functions, relations, and graphs. All right. And we need to wrap up them topics in March. We need to wrap them up, all 3 of them in March. And then in April now, the marathon is going to start. We're going to do a whole exam, whole syllabus review using past papers. And we are going to also wrap up vectors, matrices, and statistics and all that extra stuff. All right. Okay. So for tonight, let us do a quick little recap on our quadratic equations last week. Last week we learned that solving a quadratic. Oops, what is this? All right. So last week, let's see here. Okay, so last week we had looked at the topic of solving quadratic equations. Remember that I will not be available this Saturday, guys, because I will be at a function that's related to my schooling. So I won't be available this Saturday, but every other Saturday we're going to activate that. And if you guys can make a concerted effort to show up. It does help. It helps with the revision of stuff that have been taught. And I feel like my students are doing a little bit better in terms of some of the stuff that we go through. We get a chance to review stuff that we can't read during the class. So if you guys can make an effort to come, remember the marathons are going to be a little bit more expensive, So if you make a 500 class here, you want to take use of them because it won't last very long. All right. We only have 1 month left out of the 500 classes, and then the prices are going to increase as we come closer to the exam. We're going to be teaching for longer hours, so the prices are going to be a little bit higher. So take advantage of them while you can. Okay. All right. So last week we learned, I'm going to use one example to do my review. All right. So we're going to go ahead and we're going to solve the equation below. All right. I remember we said that when we say solve the equation, you have two options. You can either factor or you can use the formula, and that's a personal preference of yours. So solve the equation means that you can either factor or you can use the formula. But if I say solve the equation and I add on this extra clause here, to 2 decimal place or to 1 decimal place, you don't have a choice but to use the formula. So here, solve the equation. We're going to have 5x squared. Sorry, guys. Handwriting's a bit bad. So 5x squared minus 13x plus, what's this again? 5 times 15. Oh, so 5 times 8. Yeah, 5 times 18. All right, yeah. Yeah, man, this is it. Oh, no, it's plus here and minus here. Yeah, man, this makes sense. Equals 0. All right, so in this example here, 5x squared plus 13x minus 18 equals 0. And you're asked to solve this, right? In this case, you have an option. You can factorize or you can use the formula. I'm going to go ahead and use the formula for this one. All right. Sorry, I'm going to go ahead and factor for this one. So as you can see here, 5 times 18. Because I have the option of using the formula or factoring, I'm going to choose the factor because it's shorter. All right, so that's going to be 5 times minus 18. That's going to be equal to minus 90. I don't even have to work that hard because I've already found my factors. Look at that. 5 and 18 can work. See, already I can get back 13. So my factors are going to be 5 and 18. If I make the 18 positive and I make the 5 negative, I'll end up with positive 13. So I don't even need to list the factors because I've already found them. All right. And so going ahead then, we're going to say 5x squared. Replace this middle term here with the 2 factors selected. Minus 5x plus 18x minus 18. And that's going to be equal to 0. All right. Place them into groups of 2 like that. And then the common factor here is 5x, open bracket, 5x into 5x squared goes x times, and 5x into itself goes 1 time. And the common factor here is also going to be 18, open bracket, 18 into 18x goes x times, and 18 into 18 goes 1 time, and that's going to be equal to 0. All right. Now the common factor is x minus 1. As you can see, that's a repeated factor. And the remaining factor is going to be 5x plus 18. And that's equal to 0. Now, remember, at this stage now, that we have 2 separate brackets. We have x minus 1 equals to 0. And we have 5x plus 18. Both of them are going to be equal to 0. So in this case then, we're going to end up with x is equal to 1. So we transpose this over here. And we end up with 5x, which is equal to minus 18, because this goes over here, changes. And so x then works out to be negative 18 over 5. Okay, and that's your solution for that equation. So please keep your eyes open for quadratic equations. They'll pop up any and everywhere. All right, remember, anytime you see an equation with a square, more than likely that equation is quadratic. All right, that equation is quadratic. Lovely. Now let me give you a recap example. Now we're gonna have now we're gonna do this extra one here. Solve. I promise to use one example to do both, but okay. These are different examples. Solve the equation below. Solve the equation. So solve the equation, and here's the equation. We're gonna use 3x squared. Also, wait, let me just rewrite this. My handwriting's a bit bad. So solve the equation. Solve the equation to 1 dp. All right, so you see, the fact that I put 1 dp, it means that the equation that you're going to see on the screen will not be able to factor. All right, I wouldn't have put 1 dp if it could have been factored. That would make sense. All right, so therefore then, solve the equation to 1 dp. Let's do this here. Let's do 3x squared. 3x squared minus, let's do 4x. Let's not do that. Let's do 10x. Plus 1. All right, plus 1. And that's equal to 0. Just a minute, guys. My apologies, guys. I had to just respond quickly to someone. All right, so solve the equation to 1 decimal place. 3x squared minus 10x plus 1. As I said before, once you see the 1 decimal place, it means that it cannot be factored. So it doesn't make sense you even try. All right, so let's go ahead then and say x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. All right, and as just like last week, we're going to list out the factors of a. A is equal to 3, b is equal to minus 10, and c is equal to 1. Ms. Gentles, were you able to forward the link to the class so that for those who may have missed out last week, they would have been able to watch it? Ms. G?
When was that?
Last week when you asked me to send the quadratic videos, I think I sent it to you. Did I, or did I forget?
If you send it to me, then I would have posted it.
Okay, thank you. All right. So I have a quadratic video that explains this. For those who missed it last week, Monday's class. Last week, Mondays. I have a video that covers this in its entirety. All right, so let's go ahead and plug those numbers in and see what comes out. So we know that we're going to have x is equal to x is equal to negative. Careful now. Remember, we spoke about this last week. Remember that this negative right here, and the b is a negative 10. So you're going to have negative open bracket negative 10 plus or minus the square root of negative 10. Remember, we spoke about this also. Watch the calculator, you know. Remember, so when you square anything, you're going to get a positive number. So negative, open bracket, negative 10, plus or minus the square root of negative 10 squared, minus 4 times a, which is 3, times c, which is 1, That's going to be all sorry guys, all over 2 times 3. X then is equal to positive 10 plus or minus the square root of 100 minus 12. 4 times 3 is 12. 12 times 1 is 12. And that's going to be all over 6. X is equal to 10 plus or minus the square root of 88. 100 minus 12 is 88, and that's going to be all over 6. All right, let me just zoom out a little bit. All right, and then we're going to have X then is equal to 10 plus or minus the square root of 88 should be a little bit over 9 point change. 9 point, look a drop. How much is that? Square root of 88. Help. Square root of 88. Anybody? Help.
9.4.
9.3. 9.4, sorry.
That's okay. Thank you. 9.4 divided by 6. All right. So just like last week, we're going to do a split. X will be equal to 10 plus 9.4 over 6, or X will be equal to 10 minus 9.4 over 6. All right, and in this part now, remember, don't type everything on the calculator at once. Do the top, press equal, then divide by 6. You guys should be getting 3-point change. The default, you should be getting 3-point change. How much?
3.2.
All right, 3.2. And then at the bottom, you should also get, let me see, 0.6 divided by 6, that's 60. 0.1, confirm. X is equal to, is it 0.1? Or 0.01 or 0.1? Which one?
Yes, 0.1.
0.1. All right, and those are your solutions to the equation. All right, you can always watch the recording from last week. It thoroughly explains everything step by step, or you can watch the more basic tutorial format, which Miss G would have sent in the group last week. Okay, so you can check out that to get your review. But for tonight, for the next 1 hour, we'll be wrapping up the last topic on the algebra. We've been on the algebra from last year, so some more things to cover. Yep. So tonight, our objective is to go through simultaneous equation. Okay? Simultaneous equation. Give me a sec, guys. Hold on. Let me zoom up. Anybody needs a screenshot or something?
Yes, sir.
Take your screenshot, please. Got it?
Yes, sir.
Right, lovely. All right, so for tonight, we will be working on solving simultaneous equations. Solving simultaneous equations. All right. All right, take some notes for me, guys. It's a little bit difficult. The amount of notes is going to take up too much time to write it on the screen. So solving simultaneous equations. The general form for a pair of simultaneous equation, the general form of a pair of simultaneous equation is, I'm going to write it on the screen, AX. The general form of a pair of simultaneous equation is AX plus BY equal P, CX plus DY equals Q. This is called equation 1, and that is called equation 2. Some teachers will say equation A as well, and then they'll say equation B. Your personal choice, doesn't matter. So the general form of a pair of simultaneous equation is AX plus BY equals P and CX plus DY equals Q, where A, B, C, D, P, and Q are real numbers. All right, so the general form of a pair of simultaneous equation is AX plus BY equals P, CX plus DY equals Q, where the letters A, B, C, D, P, and Q are real numbers, whole numbers, positive and negative, positive and or negative. Full stop. Simultaneous equations are used to find simultaneous equations are used to find two distinct values. One distinct values. Simultaneous equations are used to find one distinct pair of values. I should say pair. I forgot the word pair. P-A-I-R. Simultaneous equations are used to find one pair of distinct values, or one distinct pair of values for two unknown quantities. For two unknown quantities. Full stop. These equations comes in various forms. These equation comes in various forms. These equation comes in various forms. And are easily identified. When the equation is related, and are easily identified when the equation is related to two separate quantities. When the equations are related to two separate quantities. Full stop. Final set of sentences. Below are the steps Below are the steps to solve a pair of simultaneous equations. Below are the steps to solve a pair of simultaneous equations. All right, so I'm going to list out the steps, guys, and then we're going to do a couple of examples to show you how this is applied. All right, so step 1. Select a pair. So here are the steps, guys. And if I could type, this would make it so much easier. I don't know. It's kind of, the font size so small. So the font size is so small, so large that even if I was to type, it's going to take up too much space. Okay, it's taking up too much space, so better me just delete. No. All right. This says you're not going to help. Okay, I'm going to write. All right, so step 1. So step 1 is that for the first thing you're going to do is to give your equations a name. Give your equations a name. That's very important. So give your equations a name. And usually how we do that, we can say one straight line equation 1, or sometimes you'll see them use dot, 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 and then they'll say equation 1. Or some person will say straight line and that's called equation A or B. So that is what we call name your equations. So we want to give the equations a name because later on when we need to reference an equation, we need to say, instead of writing out the whole entire equation, we just say equation A or equation B. So step 1 is to give your equations a name. You can say equation 1, equation 2, equation A, equation B, equation apple, equation whatever you want, equation X, equation Y. It's up to you. So just give your equations a name. That's the step. That's the first thing you need to do. I'm breaking down these steps. You might end up with more steps than you really need to remember. Some of them, if you can just kind of just memorize them, that's fine. Step 1 is not even. I don't even think I would even call step 1 a step, because it's just natural to give your equations a name. But I'm proper teaching it this way, and then you guys can adjust later on if you want to. So the first thing I do when I get a simultaneous equation is to give my equations a name. Step 2. I'm going to select. First thing I'm going to do is that I'm going to select a variable. I'm going to select a variable that I wish to eliminate. I'm going to select a variable that I wish to eliminate and multiply multiply by opposite coefficient. Multiply by opposite coefficients. I'm going to explain what that means in a sec. Step number 3. If the signs are the same, so if the signs are the same, writing kind of dragging, I don't know why. So if the signs are the same, we add. So same sign, subtract, sorry. If the signs are the same, we subtract. Otherwise, we add. To eliminate. Step 4. Solve the equation for the first unknown So solve the equation for the first unknown, and the final step is to substitute this value, substitute the value in either equation 1 or equation 2. So substitute the value, and when I say the value, I'm referring to the value that we got up here. So substitute the value in either equation 1. Whenever you see me write a number like this here and put a circle around it, it means an equation. Put something around here, so I'll put a number around it like that. That's equation 2. All right. So those 5 steps, it looks very wordy, but when I'm doing it, remember when I was doing quadratic factoring and I gave you a whole bunch of steps, but when we actually started to do it, you realize that it's not a lot of work. It's going to be the same thing for this one. It's a lot of words, but when you're doing it, it won't be that much work. All right. So let's zoom out a little bit here. And when needs a screenshot, my handwriting is very atrocious, but I hope you understand it.
Sir. Sir, what's the last one?
Substitute the value in equation 1 or 2. My stylus pen's a very cheap version, so it has a very big head. So I have to really, I don't have a pencil point. All right, so let us apply. I wish my teacher do something like this, man. I haven't started the research, so I think him do something like this. And when him go around it like so, like him go boom. Oh, see it there, guys, you see that? Boy, wicked. And him move it like so. Whoa. Jesus, peas. Also, him zoom it up. Oh, wicked. Bop, bop. Okay. This is what I see him do. So him draw one line around here, so. And then I think him say something like you duplicate it or something like that. Jesus, peas. May I get smart,
Posted, man. Yeah, I'm good.
All right, so yes, like you can zoom it out like that, right? Lovely. All right. Sweet. Okay. All right, Mr. Peart. Now learn, man. That's what me think me slow. All right. I want to be able to look at the steps and work out the questions at the same time. All right, so here we go. Oh, thanks for the applause, guys. All right, so here's an example. All right, hold on, wait. Let me see if we can grab one from a textbook that I have here. In fact, let me grab one from. What if I can find one from this 2008 past paper? Could I find it? Okay, can you find it? Is there one here? No. There's not one here. No. Okay, I found one, but it's not the one that I want. All right. Give me a second, guys. Let me see if I can grab an old textbook. All right. All right. Let's see one quadratic here, so. But I didn't see any simultaneous. I don't see any simultaneous here. It's okay. It's okay. It's all right. I'm gonna make one down and found you. All right, guys. I was trying to see if I found one in a textbook, but I don't find any here. I'm looking for my textbooks. I'm not a big fan of textbooks. So if you hear anything drop and I stop making sound, you know what happened to me. Just call the police. Where is your textbook, Mr. Peart? I'm gonna have to improvise. Oh, I think I found it. All right. Lovely, guys. Once I have a textbook, I can simply just use a variety of examples. I could make them up in my head in a minute. It's gonna take too much time. So let's see if we can grab some examples from here. And we can grab some worded ones as well. Lovely. We're gonna start off with something simple too. Not gonna do nothing too crazy. Nothing too crazy. All right. Okay, so here's one, guys. All right, so we are gonna be asked to solve. We're gonna be asked to solve. So solve the equation. Solve the pair. Oh, so what they usually write is that they usually write solve the pair of simultaneous equation. No, they usually write solve the pair of equations for x and y. So they normally write it for x and y. All right, and here's the equation that they've given us. Sorry, here's the equation that I'm giving you. 5x plus 3y equals 21. And then the other equation is going to be 2x plus 7y equals 20. So that is how it normally looks. For those of you who have done math before, this is not unfamiliar territory. All right. So for those of you who are seeing this for the first time, pay close attention. All right. So we're going to zoom out a little bit here and follow the steps. All right. So for step one, first thing they say that we should do is to give our equations a name. All right. So I'm going to go ahead. I'm going to draw a straight line here. Equation 1 and equation 2. That is step 1. So easy. Step 1, always give your equations a name. All right, step 2, select. So it's a choice you're going to make, You're going to select the variable. Remember that the variables are what? X and Y. So you're going to choose one. Select the variable that you wish to eliminate. And once you've made that decision as to which one you want to eliminate, you're going to multiply by opposite coefficient. Let me explain that part to you. So, traditionally, you'll hear a lot of high school teachers tell you to eliminate the Y, right? And it's a reason why we tell you to do that. Because, let me not tell you because. It's a reason why we tell you to always focus on eliminating the Y. But I'm going to do examples and show you that even if you eliminate the X, it's going to be the same thing. So for this one, we're going to choose to eliminate the middle term. So what do you mean eliminate? We're going to get rid of it. How do you do that? Well, watch carefully. Watch carefully now. There's a 7 down here. I'm going to multiply up here by 7. And there's a 3 up here. I'm going to multiply down here by 3. Sir, do that again. Sure, no problem. Because I've chosen to eliminate these two, those are the ones that I want to get rid of. I'm going to look at the numbers that are in front of the letters Y. And because there's a 7 here, right at the bottom, I'm going to multiply the top equation by 7. And since there's that 3 at the top here, I'm going to multiply the bottom equation by 3. Many students get confused and they always ask me after 2 or 3 examples, sir, how you get them numbers there side again? The numbers that I'm using are not numbers that I grabbed from thin air. I'm using the numbers that are already in the equation. So if I had chosen, let me just use a different color ink. If I had chosen to eliminate the x's, what I would have done was that I would have multiplied down here by 5 and multiplied up here by 2. Because there's a 5 here, so I multiply down at the bottom equation by 5. And then because there's a 2 here, I multiply the top equation by 2. So that's how I'm getting the numbers at the side. All right, so it's not magic. So that's what I'm doing, guys. Lovely. So any questions on that? So I've chosen to eliminate the y's. And that's how I got the 7 and the 3. All right. Now remember, you're going to multiply everything by 7. Not just the middle. Everything going across this direction. And everything go across like that. So watch me now. The 7 multiplied by the 5x is 35x. The 7 multiplied by the 3 will give us 21y. 7 multiplied by 21, that's going to give us 147. This will become equation 3. Again, the 7 that I have out here will be used to multiply this, and this. So that's how I got the 35, because the 7 times the 5 is 35. The 7 times the 3 is 21. The 7 times the 21 is 147. So that's how I'm getting my answers. All right, now I'm going to repeat the process now for 3. 3 times 2x, 6x. 3 times 7, so watch, this 3 times this 2x gives me 6x. This 3 times this 7y gives me 21y. And this 3 times this 20 will give me 60. And that becomes equation 4. All right, lovely. So now that I've created two more equations here, what I'm going to do next, interestingly, what I'm going to do next is I'm going to check step number 3. What does step number 3 say? Step number 3 says that if the signs, let's read it here. Let's put a different color ink, or let's use red. No, let's use green. So let's read number 3. If the signs are the same, we are going to subtract. If they are not the same, that's what the word otherwise mean, we're going to add. So read again. If the signs in the middle are the same, meaning plus plus or minus minus, you're going to subtract the top from the bottom from the top. Pardon me, give me a minute. My apologies, guys. All right, so if the signs are the same, we subtract. Otherwise, we are going to add to eliminate. So if you scroll back down to this question here and pay close attention to the signs in the middle, they are the same, not true? So what that means is that because the signs are the same, we're going to subtract the bottom from the top. So you see them subtraction sign there? Those subtraction signs are as a result of the signs being the same. Notice I've circled them in green. I circle the plus signs in green to show you that those signs are the same. That's where those minus signs are coming from. So we're going to go ahead and subtract this from this. All right, those green signs. 35 minus 6 will give us 29. And look at this, 21 minus 21, 0. That's why we call it the elimination method. So 21 minus 21, 0. Positive 21 minus positive 21 will give us 0. And 147 minus 60, that's going to give us 80 something. 80 something?
87.
87. Thank you so much. All right. And that completes step 3. Look at step 4 now. Step 4 says what now? Solve the equation for the first unknown. So solve the equation. Remember, so we just come off of algebra the other day, equations. So whenever a number is in front of a variable, we're going to divide by that number. So x is going to equal to 87 divided by 29. On your maths up that, you're going to get a sweet little number here. X equals 3. Sir, are we always going to get nice numbers like 3? Not necessarily. Majority of the time, yeah. But don't set your mind on it. Okay, you can get answers like a half, a quarter, depending on how cruel the teacher is. So you can get answers like a half, 2/3, 1/5, 2/5, 3/8. You're not going to get nasty numbers like 11 over 145. You're not going to get numbers like that. You're going to get nice numbers like half, a quarter, 2/3, 3/5, so on, so on, so forth. All right?
Excuse me, sir.
Yes, go ahead.
You can repeat step 3.
Step 3, if the signs are the same. Step 3, after I've made the numbers in the middle the same, after I multiply by 7 and multiply by 3, I'm going to look at the signs in the middle right here. And if I observe and I realize that the signs are the same, the rule is that you're going to subtract. So it says same signs we subtract. So I subtract and I say 35 minus 6, 21 minus 21, 147 minus 60. And that's what gives me 29x equals 87. I then divide both sides by 29 and I get x equals 3. Clear? Everything Gucci?
Yes, sir.
Lovely. All right. So we're going to then finally know step 5, substitute. See it here? Substitute the value we just get a while ago, which is the 3. You're going to substitute that in equation 1 or 2. So choose any one. It doesn't matter which one. It doesn't matter. So I'm going to sub the number 3 4x. So I'm going to sub the number 3. Because I'm going to say x is 3 now. So I'm going to sub the number 3 for the letter x, 4x. And I'm going to choose an equation. It doesn't matter. I'm going to choose the smallest one. I'm going to choose equation 2. It has smaller numbers, 2 and 7 and 20. I could choose equation 1 if I want to. It's the same thing. So now I'm going to put the number 3 for the letter x in equation 2. And here's equation 2 right here. So I'm going to have 2 times 3 plus 7y equals 20. So 6 plus 7y equals 20. And I believe that we've gone through this stage already. Bring over the 6 over there. So 7y equals 20 minus 6. 7y equals 14. So you know, so y I got equal to 14 divided by 7. Y will be equal to 2. Nice solution. All right. So we had to learn equations. We had to go through the whole process of solving equations before we got here. This would be very chaotic if we got to this point without having a thorough understanding of how to carry over, change signs, divide by, multiply both sides by, all that extra stuff. All right. So that is one example there. We would need another example to verify everything. Right? So that one example is not going to be enough. So let's take on another example and see how best we can do. And this method is called the elimination method. All right, I'll teach you the substitution method when I start the topic of functions and relations. But for now, we're just going to focus on the elim method because we're in section 1 of the paper. All right, lovely. Lovely, 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 lovely. I said, guys, I really want to learn how to duplicate this thing. Oh, Lord. I want to learn how to duplicate it. Chai. I don't know how to duplicate. I know I can put I know how to do this part now. What I want to do is that I want to duplicate this. It gives me some options here. Ah, guys, I got it. Look at this. Look at this, guys. Look at this. And I see that. Wicked. Wicked. So we can just carry back down this right here. So nice. Jesus. So Peter, bud. So I can just do another example and just have you guys just look at. Yeah, man. See? Never stop trying until we get it. Thank you, Dominic. Yeah, man. Nice. So you see, I can just transfer the things that I've written already and just bring it down and just repeat the process. Lovely. Fantastico. My lecturer not have nothing for me now, guys. I'm bad like him now. I wish. I really do wish. All right. I'm learning. Okay. Here's an example now. We are going to look at this example here. 3x plus 2y equals 5 and 4x minus 3y equals 18. We're going to eliminate the y again, all right? We're going to eliminate the y. There's a reason why I want to eliminate the y because I want to bring across the point of the different signs. So I'm going to go again. I'm going to eliminate the y. So 18. Oh, yes, 18. Oh, yeah, 18. All right, guys, ready again. So Step 1, give the equations a name. Equations a name. Equation 2. All right, once I've given my equations a name, I've already made my choice. I've already decided I'm going to go ahead and I'm going to. Those are the ones that I want to eliminate. So therefore, I'm going to multiply. I'm going to go ahead and I'm going to multiply this equation up here by 3 and this equation down here by 2. All right, so let's go ahead and multiply by 3. 3 times this, that's 9x. 3 times this, plus 6y. 3 times this, 15. That's equation 3. Now I'm going to go 2 times this, that's 8x. 2 times this, that's negative 6y. 2 times 18, that's going to give me 36. That is equation 4. Now, observe. Observe very carefully. If you observe very carefully, you realize that these two signs in here are different. Look at the previous example. Those two signs, look at this. These two signs here are different. So according to the rules that we see here, right here at what? Step 3, it says that if the signs are the same, we subtract. Otherwise meaning what? If it's not the same. And in this example, it is not the same. So therefore, we are going to what? Add to eliminate. That's the rule. So we're going to go ahead then and we're going to add. We're going to add here, and add here. Add the top to the bottom. So we're going to end up then with 9x plus 8x is 17x. And 6y plus negative, you're adding two numbers that have opposite signs, that's going to be 0. And 15 plus 36, I believe that's going to give us 51. And just like before, we're going to go ahead and divide both sides by 17. So 51 divided by 17, we get a nice sweet result of x equals 3. So is it always going to be 3? No, obviously not, guys. It's just coincidental that the two questions that I've chosen, it works out that x is 3. It's coincidental. So therefore then, for the final step now, step 5, I'm going to substitute. I'm going to substitute 3, 4x. The last time I placed it in equation 2, I'm going to put it in equation 1, show it's the same result. So I'm going to put the number 3 for the letter x in this equation right here up top, number 1. Which is going to be 3 times 3 plus 2y equals 15. 9 plus 2y equals 15.
Sir, is it 15 or 5?
Oh yes, a 5. Thank you. Thank you, dear. Thank you very much. All right. And then I'm going to go ahead now and I'm going to say, bring over this. So I'm going to end up with 2y equals 5 minus 9. Got the 9 move over and become minus. So you have 2y equals to negative 4. Y equals negative 4 divided by 2. So y equals minus 2. In this case, y is minus 2. All right. So that is how you work out that equation there. Yeah? Lovely. All right. I want to try this again. It's fun. It's really fun. Come in, Mr. PH. Show them your style. Wicked. So much stuff me have. Yes. Bob. Come in, Mr. PH. Show them your style, yes. All right. All right. So can you even grab all of this again? That's you. Move it down a little bit, right? Zoom it up, so. Cool. Nice. All right. So we did an example with them having the same signs. We did an example with them having different signs. Let's look at an example now that's worded. We're coming to the end of the class. Let's look at an example that's worded. And we're not going too hard on it, we're just keeping it simple. All right, write this down for me, guys. It's a worded question, so I can't write it on the screen. It doesn't take too long. All right, write this for me, guys. Worded question, example. A boy bought 3 rotis, R-O-T-I-S. A boy bought 3 rotis and 4 pies from a shop. A boy bought 3 rotis and 4 pies from a shop and received $7.50 change from $40. Why am I switch up the question, so? Oh Lord. A boy bought 3 rotis and 4 pies from a shop and received $7.50, that's 7.50 change from $40. Full stop. If he had bought 4 rotis, if he had bought 4 rotis and 3 pies from the same shop, if he had bought 4 rotis and 3 pies from the same shop, then his change would have been 75 cents. Then his change would have been 75 cents. That is 0.75. So $0.75. 0.75. The instructions are 1. Write a pair of simultaneous equations. Write a pair of equations. Part 1. Write a pair of equations. Write a pair of equations that represents the above scenario. Write a pair of equations that represents the above scenario. And to do that, that's going to be 2 marks, guys. 2 marks to do that. And part 2, calculate the cost of 1 roti and 1 pie. Calculate the cost of 1 roti and 1 pie. Calculate the cost of 1 roti and 1 pie. All right. So, I didn't mean to go this hard on this question, you know. But, you know, we're going to deal with it the same way. All right, lovely. Let's do some zooming up here. So in the usual way, if you want to let roti be X and let pi be Y, that's going to just make the problem a little bit too hard, right? So what I would do, right? What I would do, and just make life easy for myself, is I'm going to start by saying let roti equals R and and pi equals P. That me I do. So I'm going to say R is roti and P is pi. If you want to say let roti equals X, pi equals Y, or roti equals Y, pi equals X, it's up to you, right? It's up to you. So for this here, I'm going to start off by saying let roti equals R and pi equals P. All right? Let's create the equation now. So based on what yes, question? Somebody has a question?
Yes, sir. The last part where you say his change would have been
75 cents.
Okay, sir.
Thank you. All right, good. So let roti equals R and pi equals P. Let us read and interpret. Them say the boy bought 3 rotis. So he buys 3R and he bought 4 pies. So he buy 4P. The challenge in this question is finding out how much money did he pay for the 3Rs and the 4 pies. Can anybody guess? And can you guess or can you tell me how I would know what number to put here? The boy bought 3 rotis and 4 pies from a shop and he received $7.50 change from a $40 bill. How would I know what number to put there? What number should I put there and how did you get it? Him get $7.50 change when he bought out of $40.
I would say the 32.50, which is the answer when you subtract the change from the $40 that was presented originally.
Very good. And that is equation 1. Now, another situation popped up where he said that if he had bought 4 rotis instead and he bought 3 pies, so my 3P, his change would have been 75 cents. What number would I put here? $0.75.
39.25.
39.25. All right, equation 2. Any questions on that, anybody? So that is the interpretation and comprehension behind the question, right? Some person would make mistake and put down 40. Some person would make mistake and put down $7.50. Put down all different type of numbers. You have to read and interpret. They say that he got change when he paid for them out of $40. So you take away the change him get from the money when buy it out of, and you know how much him spend. So you've created 2 equations there. That's your 2 marks. That's all that's required for that part of the question. 2 marks. 1 mark for the first one, 1 mark for the second one. Step 2. Our problem number 2. We are to then calculate the cost of 1 roti and 1 pie. So they want us to find the value of R and find the value of P. So in similar fashion, we're going to go ahead and we're going to decide which one we want to eliminate For this example, because the first two examples I eliminated the ones in the middle, for this example, I'm going to eliminate the ones at the end, at the front, just to make sure everything is covered. So I'm going to eliminate the 3 and the 3 and the 4, right? So I'm going to go ahead, I'm going to multiply up here by 4 and multiply down here by 3. I'm experimenting. If you guys want to go ahead and, you know, multiply, well, at the same thing. Okay, well, in this case, it doesn't matter. If you're eliminating the middle, if you're eliminating the middle, you'd multiply down here by 4 and up here by 3. All right? Uh-oh. It's appeared. Let's go ahead and do that. Everything by 4. So 4 times 3r, 12r. 4 times 4p, 16p. This part I need help with. 4 times 3250. That's 128, 130. Confirm, please.
130.
Okay. Good guess, Mr. Peart. All right. 3 times 4r, 12r. 3 times 3p, 9p. I know we need help with this now. 3 times 39.25. That is 108, 109.
117.75.
Oh, God. I'm not a very good teacher. And 17.25.
75.
And that's going to be equation 4. All right. Now, I'm going to pay close attention to that part here, because here's where you guys might get caught. Might get caught. Now, here's why teachers always tell you to eliminate the middle. Because your eyes, you know, your learning eyes is fixated on the signs here. And if you notice that those two signs belong to the 16 and belong to the 9. So those aren't the signs you're supposed to pay attention to. You pay attention to the signs that are in front here. So yes, in this case, they're the same signs, but many times I catch students by putting 2 different signs at the end, and them eyes are fixated on this. So when them see same signs, them run go subtract. When if there's a different sign out here, let's say it was a plus and a minus out here, and there was a plus and plus in the middle, I catch them off guard because their eyes are fixated on the middle. So them say, oh, same sign, sir, so must subtract. But the signs that you're supposed to focus on are the signs of the terms that are equalized. So a lot of the times I catch students like that. All right? I usually end up with some really nasty answers. Some answers will not make no sense. But in this case, you're not going to get caught. In this case, because the signs of the 12 are the same, plus and plus, you get away with it. You're going to minus, minus, and minus. All right, so 12r minus 12r is 0. Obviously, that's gone. 16p minus 9p, that works out to be 7p. And what is 130 minus 117.75? That sound like, boy, that sound like 12.25. How many sound?
Yes, sir.
All right, and you just go ahead now and divide both sides by 7, and you'll get the cost of a pi. So 1 pi will cost, go ahead, guys. What is 12.25 divided by 7? How much for a pi?
1.75.
$1.75 for a pi. Now, in the usual format, we're going to sub 1.75 for p in. Choose equation 1 or 2. I like equation. It no matter which one. I like the number with the smallest. Less calculation, better calculation for me. So I'm going to go with equation 1. But you can try equation 2 if you want to. So anyway, I say p, I'm going to put 1.75. So I'm going to have 3r plus 4 times 1.75 and that's equal to 32.50. So if we're going to get decimals, whenever the question is a realistic question, like an actual question that is a real life example, you'll end up with real values. Real values meaning like decimals, money values. So then 3R plus, I believe, if I'm not wrong, if I can do my, yes? Yes, go ahead, question.
This substitute for P? Or
Yeah.
for R? Okay.
I substituted for P, not for R, because P is 1.75. So 2 times 75 is 1.50, 4 times 75 is 3. So that's 7. Is it 7? I think so. I think it's 7.
We're in the same thing, sir.
Pardon me?
That's 1.75.
Yeah, 4 times 1.75, is it 7?
Yes, sir.
Okay, lovely. Bring that over there. I'm going to get 3R equals 32.50 minus $7. 3R works out nicely to be equal to, oh Lord, 25.50 or 24.50. One, 30, 29, 28, 27, 26, 25. 25.50. Confirmation? Confirmation?
25.5 again.
I see I'm only, so 50. I'm only. So 25.5, there's no number after the 5, so it's 0, it's assumed. So one roti will be equal to 25.5 or 50 divided by 3. How much for a roti? Is it $8.5? $8.50?
Okay.
Is that it?
Yeah.
Yes, sir.
Yes, sir.
Lovely. So one pie is 1.75 and one roti is $8.50. All right. That is how you actually evaluate a pure simultaneous equation. And as I said, the question comes in many forms. What you can do, right? And you can do your thing on your own. Oh, you guys are not seeing my screen, so you won't be. Type in simultaneous equation worksheet PDF, and then you're gonna see a PDF file come up, or you can type in simultaneous equation Csec worksheet. Simultaneous equation Csec worksheet, and there's this guy by the name of Csec Math Tutor. He usually has like this bunch of PDF documents with a bunch of simultaneous questions in there. You can practice them. All right, but that brings us to the end of the topic of algebra. It brings us to the end of this class, and it's leading us into our holiday, right? It's the beginning of Lent, 40 days that Jesus fasted in the wilderness. So please have yourselves a productive rest of week, a productive and safe holiday. I want to hear back from all 24 of you guys next week, Monday, where we are going to bring in our topic of geometry. All right, so until then, be safe, have a good night.
Thank you, sir. Good night.
You too. Thanks.
Good night, sir.
Answer.